Hi everyone, welcome back to Nanome. Today I'm going to be talking about a publication that I actually reviewed on my channel maybe 6 months, a year ago. I don't exactly remember, but it was a publication that looked at a compound in the cannabis plant called THCP, which is basically THC but with a 7 carbon chain. And in this paper, they showed that not only did it show stronger effects in animals, but it also showed higher affinity at the cannabinoid type 1 receptor. And they did some modeling in the paper. And I wanted to look at that from a an in silico perspective and why this compound might have stronger affinity and just kind of talk about the research behind all this. So as you can see in front of me, what I have is I actually have two molecules overlaid on top of one another right here. What I have right in front of me are these two molecules. The one in this fluorescent green is THC, and the one in blue is THCP. If I kind of pull them away, we kind of see the differences between the two compounds. The only difference among these two compounds is that THC has a 5 carbon chain right here, 1, 2, 3, 4, 5. THCP, on the other hand, has a 7 carbon chain, 1, 2, 3, 4, 5, 6, 7. So what we're going to be talking about is why does this compound THCP show stronger affinity to CB1, but also show stronger effects in animals. Basically, it'll, at the same dose, it'll produce more intoxicating like effects. It's interesting to see that in the cannabis plant, there are compounds other than THC that are actually more potent than THC, and we're going to talk about that a little bit today and offer up some reasons as to why. So these are the two compounds. Enjoy them, THC and THCP, if you do use the cannabis plant. So let's see. So what we're going to bring up now, as usual in a lot of my videos, is let's look at the cannabinoid type 1 receptor. The scroll wheel here just controls how dark the surface is shown. So if I crank it up a little bit, it'll get darker and darker and darker. I usually like to put it pretty dark, so that we can see a defined pocket where the ligand might actually get inside the receptor. So if we take a look around the cannabinoid type 1 receptor, I don't see any holes near the helices, but usually on the top part of these receptors, there are usually holes. I see one hole right here, okay, that a ligand can possibly swiggle its way through to get inside the active site. If you guys notice, there's this gray sort of pocket right here, and that's usually the binding site. And surface mode really shows that a lot really well. You can see the binding site defined. Okay, so let's put THC inside the binding site. Cannabinol. Okay, cool. Yeah. Generally speaking, cannabinoids like THC type do bind at the orthosteric binding site. So if we look at THC inside the binding site, we can actually see why looking at this via a surface is super helpful. We can see sort of the pocket of this baseball glove, as I use in a lot of my analogies. It's pretty big, and THC actually fits fairly well inside this binding pocket. There's a little bit of room over here that isn't occupied inside the binding site, and there's probably a little bit of room up here that's not occupied inside the binding site. So we have a glide score shown, as I show a lot, because we're going to compare THC to THCP. So let's overlay THCP with THC. Okay, very cool. Now that we have THCP overlaid with THC, we can probably begin to sort of talk our way through why THCP shows better binding affinity to CB1 and also stronger cannabimimetic properties, meaning that it shows it's more potent than THC. So first off, the poses are basically identical up until a point. The rings up here line up perfectly, the rings over here line up perfectly, even the carbon chain lines up perfectly. But when it changes is when you go from that 5-carbon ring to a 7-carbon ring. And sort of what I think is going on here is that there's this aromatic amino acid here, tryptophan. Okay, so the THCP, because it's a little bit longer, it's probably going to interact a little bit stronger with this tryptophan aromatic amino acid, as well as this leucine amino acid right here, and as well as this phenylalanine right here. So basically, what the caveat here is that these amino acids that THCP is interacting stronger with are all on a specific helix. This is helix 5. So what I think is that because THCP is pressing harder on helix 5, it's probably stabilizing that whole helix into a specific conformation, leading to higher potency of the compound. The more you can stabilize the ligand receptor G protein complex into one conformation versus another, you're probably going to favor that conformation overall. So this probably favors a conformation that binds to G protein better than it would without the 2-carbon chain. And it also, shows higher affinity once again because it has the same exact pose, but it interacts hydrophobically with these additional amino acids. But I'd like to hear what you guys think. Why do you guys think, from this standpoint, THCP has greater potency and binding affinity than THC? This is all me guessing. I did read the paper. The paper just talked about basically how the hydrocarbon chain goes deeper into this hydrophobic pocket, but it didn't suggest a sort of more in-depth theory as to why it showed higher potency and affinity from this perspective. So, with that being said, I'd love to hear what you guys think. Why do you guys think this compound shows greater potency and affinity to CB1? And with that being said, talk to you guys next time. Bye.